Hello viewers, today we are going to solve one more problem in nodal analysis. So in the given circuit, you need to find out the current flowing through individual branches. Okay. So what is the first step in nodal analysis? The first step is you need to identify the number of nodes in the given circuit. So in the given circuit, there are three nodes. So this is our first node and second node, third node, and including your reference node there are four nodes. Total number of nodes are 4. So this is considered as reference node. So fourth node is your reference node. So this is one node, another node, but all the nodes are connected by a common wire, so we consider it as a common node. So fourth node is the reference node. Okay. Second step, you have to assume the node potential. Node 1 potential is V1, node 2 potential is V2, node 3 potential is V3, your reference node potential is 0. So this is our next step. Next, you need to assume the branch current in the given circuit. So next step, you have to assume the branch current. So this is my first branch. So assume the current I1. This I1 current is further divided as I2, I3 and I4. Again this I3 current is divided as I5. So here we have 5 ampere of current source. You no need to label the current source. Just keep as it is. So now the current is I5. I5 current is further divided as I6 and I7. So there are 7 branch currents from I1 to I7. Next step, you have to apply KCL for individual nodes. At node 1, apply KCL. So what is KCL? In a node or junction, sum of incoming current equal to sum of outgoing current. So your I1 is incoming current with respect to node 1, but I2, I3, I4, all the currents are outgoing current, are considered as outgoing current because it is away from the node. So we can write the KCL. I1 is incoming current, I2, I3, I4 all are outgoing current. We know very well by Ohm's law I equal to V by R. Your current I1 is flowing from plus 10 volt to V1 potential. It means the battery positive plate has 10 volt, negative plate has 0 volt. Your I1 current is flowing from plus 10 volt to V1 volts. So potential difference is 10 minus V1 divided by the resistance 10 ohm. The resistance is 10 ohm equal to I2. Your I2 current is flowing from V1 potential to V2 potential. So I2 can be written as V1 minus V2, that is starting potential minus ending potential. So V1 to V2, V1 minus V2 divided by resistance 3. Similarly, your I3 current is also flowing from V1 potential to V2 potential. Your current starting point is V2, your current ending potential is V3. So V1 minus V2. Again V1 minus V2 divided by 3, resistance is 3. And what about your I4? Your I4 current is flowing from V1 potential to 0 potential. So V1 minus 0 divided by the resistance is 5 ohm. Solve the equation, you will get 0.967 V1 minus 0.66 V2 plus 0 into V3 equal to 1. So this is our first equation. Next, Let us write the KCL for node 2. At node 2, apply KCL. So what is KCL? Sum of incoming current equal to sum of outgoing current. With respect to node 2, I3, I2 are incoming currents. So, and what about your 5 ampere? Your 5 ampere also flowing towards the node. So I can write I2 plus I3 plus 5 equal to your I5 current is outgoing current. So write it in the right hand side. So I5. What about direction of I2? Your I2 is flowing from V2 potential to, V1 potential to V2 potential. So I2 can be written as V1 minus V2 divided by 3. And I3 current also flowing from V1 to V2 potential. Potential difference is V1 minus V2 divided by 3 plus 5 is the current source. They have already given the current 5 ampere. You no need to label it. I5 is flowing from V2 to V3 potential. So V2 to V3. So V2 minus V3 divided by 2. V2 minus V3 divided by 2. Solve this equation. You will get 0.66 V1 minus 1.16 V2 plus 0.5 V3 equal to minus 5. Let it be equation number 2. Similarly, at node 3, apply KCL. So we know KCL, sum of incoming current equal to sum of outgoing current. With respect to node 3, this is our third node. I5 is incoming current, I6 and I7 are outgoing current. So this can be written as I5 equal to I6 plus I7. I5 is flowing from V2 potential to V3 potential. So potential difference is V2 minus V3. The resistance 2 ohm. So V2 minus V3 divided by 2 equal to I6. The current I6 is flowing from V3 potential to 0 potential. So V3 minus 0 divided by V3 minus 0 divided by 1. Similarly, I7 also flowing from V3 minus 0 divided by 6 ohm. Since V3 minus 0 divided by 6 ohm. Solve the equation. You will get 0 V1 plus 0.5 V2 minus 1.6 V3 equal to 0. Write the three equation in matrix form. Write the three equation in matrix form. It will become 0.967 minus 0.66 0. Second equation 0.66 minus 1.16 0 plus 0.5. Third equation 0.5 minus 1.67. The unknowns are V1, V2, V3. The right hand side elements are 1, minus 5, 0. Using Cramer's rule, V1 equal to del V1 by del, V2 equal to del V2 by del, and V3 equal to del V3 by del. So V1 is 7.96 volt and V2 10.15 volt and V3 3.03 volt. Thank you.